So, good stuff. Okay, log base 2 of 19. Now, this isn't as crucial as it used to be because now your fancy pants calculators do any base. But it used to be the case that your calculator only did base 10 or base E. You had to be able to change the bases. For calculus purposes, you still have to be able to do this. So this is an important skill. The idea is to put this into base 10. I think you'll agree right now it's base 2. Let's start by call it x equals log base 2 of 19. Rather than just some floating log base 2 of 19, give it an x. Give it x. Call it x. All right? Now, your goal, should you choose to accept it, is get rid of log base 2 and get log base 10. So what do you want to do?
No log.
No log. Okay, so let's dump the log. How do you dump the log? 2 to the. So now it's 2 to the x equals 19. Okay, now that's the first part of the mission, get rid of log base 2. Now it is get base 10. So now what? Take the log of both sides. If you don't write a subscript, then it is assumed to be base 10. Okay, so cool. Now our question though is now solve for x. So now solve for x by putting x in front. X log of 2 equals log of 19, and therefore x is what?
You lost me.
I put x in front. Log 19 divided by log 10. I just changed the base. I changed the base from log 2 to log 10. Yes.
Why would you even change it from? Oh, never mind.
Okay. Okay. Are you with me?
Yes.
Now you do log base C or natural log.
Okay. So using what?
It is
the log.
very much the same idea. Still, you're changing log base 2 of 19, but now you're taking this, and instead of putting it in log base 10 like we did here, I want it in log base Z or natural log here. So start by the same process. Say let x equal log base 2 of 19. Your goal is through accepting rules of math to change x to natural log. So the first thing, how do you get rid of, what do you want to get rid of first? Log base 2. So the first part is not natural log or E, it's get rid of log base 2. So 2. Wait.
Yeah.
Oops. Now what's the problem? What's 2 to the x equals 19. Okay? Yes. Okay, so now just like instead of over here you wanted log, we want natural log. So now we're going to take the log of both sides, yeah? Okay? Now your goal is to get x by itself. Now what do? Bring the x down, so you have x times the natural log of 2 equals the natural log of 19. And then finally get x by itself. So x is? Natural log of 2. Yeah, that was pretty straightforward. That'll help you integrate later in calculus, but that's for another day.
How come
Yep.
you do it to the natural log and not to is natural log
Where natural log is the same as log base E. Yes. Okay. Okay. Next idea. Actually, before we get to the next idea, would you come over here? And I want to make sure you understand a little something about notation. So, look at those 5 things. Tell me which of them are the same. A is the same as E. Any others?
D is the same as no.
B is the same as D.
Okay.
C and D are the same.
So you say A is the same as E. I agree. Okay.
C and D are the same. No, C if you add them together makes 2 elements.
So what about B? If there's no parentheses, it's assumed the square is on the x. So if you don't see parentheses, assume that. Therefore, B is the same as D. What about C? Is it the same as anything? What's log of 2 plus log of 3 equal to? Log of, not 5. 6. So the log of A plus B, or log of A plus the log of B is equal to? Okay, so I ask you again, what is C the same as? It is the same as D and B. These are all the same. Okay? All right, now keep that in mind as far as notation. Now, next thing. These tend to present problems if you look at it lots of ways. So I've tried to make it so it's all streamlined here. It's kind of like when you have this guy here, 2 cosine squared plus 3 sine plus 2. The same idea happens at lots of places in that. What's the first thing you do and why? You change cosine squared to sine squared. Why? So they're more like terms. Okay, so it's like one type of function. The same goes here. These are different. That's log of x squared. That's log of x. Those are different. That's a problem. Okay? This is log of square root of x. That's log of normal x. Those are different. That's a problem. So the first thing you want to do is make arguments the same. Now this thing, how can I make those arguments the same so they're both natural log of the same thing? Exponent rules. What about the 2? Which of these 2's can be brought down? This one or that one?
That one.
The left one or the right one? The left. This one can be brought down. Okay? We just made the arguments. Do you understand what the math word arguments means? It's the thing inside the function. So for example, if I said, hey, f is the square root of 2x, you'd say the argument is 2x. If I said, hey, the sine of 3x, then the argument is 3x. It's the inside part of the function. Now, that's atrocious. Okay. Are you down so far? All right. Next, fight the temptation. Do not divide out a log. You will lose a solution. That is the temptation for students. They say, oh, now I can divide a log out. And I totally understand it makes your life easier, but you lose a solution that way. Pause for a second. Come over here. X squared equals x. If you divide both sides by x, what do you get for an answer? 1. Okay? Do you agree that if you divide out an x, you get x equals 1? That's terrible math. You just lost a solution. This is bad math. You never divide out a variable. Instead, there is a proper way to do it. What is it? Move it to one side. Then what? Factor. And then solve. There isn't one solution. There are 2. Never divide out a variable. You lose solutions that way. So here, you're going to fight the temptation to divide out a log. Bad math. And instead, you're going to do like we did over here. What did we do over here the right way? Move everything over. So if I move everything over, then I would get natural log all squared minus 2 log of x. Yay? Then what? Factor out a natural log of x. What's left inside? The natural log of x minus 2. Now, if this times that equals 0, then surely natural log needs to be 0, or natural log of x minus 2 needs to be 0. That's called the zero factor theorem, or the zero product rule. Now, how do you solve natural log of x equals 0? You e it, and so x is e to the 0, which is not 0, it is 1. And this is natural log of x equals 2, then e it, so x is
E squared.
e squared. Your two solutions are x equal 1 and x equal e squared. Are you with me? Are you with me? Okay. Similar, but not quite the same, is this. Again, first thing you should do is make arguments the same. Right now, this is log of root x, and that's log of normal x. That's bad. We want them to be log of the same thing. So how do we change this back? Cannot square it. To the 1/2, and then move the 1/2 down. Now, are they the same argument or same thing inside the log? They're both log of normal old x. Follow? All right. Now what do we do? Now if I move it over, is squaring going to be harder? Yes. So instead, now we're going to square. Be careful. This is over here. What would you say is on the left side? 1/4 log of x squared, all in parentheses, or just x that's squared? All in parentheses. The whole thing is squared. Log times log, not log of xx. It's the log of x times the log of x. You follow? And on the right side, log of x. Now what? Move it over. I love that you didn't say divide out a log. That's great. Way to learn. 1/4 log squared minus log of x equals 0. Then what? You're well said, Hannah. Factor out a log. They have a common factor of log. Mr. McCabe, when I factor out a log, what do I have?
X.
No, try again.
1/4 log x.
1/4 log of x minus 1. If a times b equals 0, then either a, or the first thing has to be 0, or b, the second thing has to be 0. If log of x equals 0, how do I get rid of log of x? Log to get x. You exponentiate, so that, and what is 10 to the 0? 1. Okay? What about the other one? What 3 steps in order do you do to solve for x? Move the 1. Divide by 4th would be better. Multiply by 4. Let's do those two. Do you agree that if I move the 1, multiply by 4, I'd get log of x needs to equal 4? Which means then I get rid of log by 10 4. Good buddy. Yes, 10ing it, or also known as exponentiating it. So x is 10 to the 4th, which is what? 10,000 or 1,000 or 100,000? So what is it? 10,000, yes. So your answers are 10 to the 4th and 1.
Did you say 40?
40 is
That's
not
so
real. Yes, 10 times 2 times 10 is so. All right, last row. Here we go. Super easy. These are the easiest ones. Save the easiest for last. So, Kiriana, what do I do to get rid of the log? Do what? What is the opposite of log, people? 10. Okay, so 10 each side. When I 10 each side, what is the left side going to become? Does it get rid of both logs or just the outer log? Just the outer log. So now we have log of x equals 10 to the 5th. Or if you like, 1 with 5 zeros, which is 100,000. And how do you get rid of that then? Or that log? You 10 it again. So x is 10 to the 10 to the 5th, or 10 to the 100,000th power And that is one with, what, 100,000 zeros after it.
Can we leave it 10?
No, I want you to write one with 100,000 zeros after it.
Just like, I feel like it's something else.
Are you with me?
So,
Okay. Almost done. Now what? 5. How do you get x by itself?
put it in the front.
Log it so that you can use a log rule. But whatever you do to one side, you do to the other. Now, if I do that, then the log rule says I bring down the root log, multiply it times normal log. And the right side is 8. Okay, cool. Are the arguments the same? I disagree. They are the same. They are both log of x. Okay, good job. So, what now? Think of it like this. If you had root u times u equals 8, what would you do? I think that would super be counterproductive. It's already square rooted. So you could square both sides, or you could combine them. So you're saying square both sides.
No, actually, we should just do. Can we leave the log x on the outside and then just put
Oh,
it
you
on the
cannot
top?
square parts here. You must square the whole side in time.
No, like no. Like we wrote it like could we like move this part to the front
Yes, you
and then just put it to the 10?
No, you have to combine into a single log. So that's a good call, but no. Okay, so what is the left-hand side when you square it? Log of x all squared. Notice the parentheses. It's not just x squared, it's the whole thing squared equals 64. Cool. Now what? It's already factored, so try.
Log of x times log of x.
Square root would take you right back to when you just were.
Cube root. It's a cube.
Yes, do you agree that log, this is altogether 3 logs multiplied? Yes?
Can we cube root it now?
Now you can cube root it. The log of x is
How much happens? 4.
4. Wow, this is disastrous.
And then you do it to the 10.
And 10 it,
So
x is
10 to the 4.
10 to the 4th. So 10 to the 4th is fine, or 10,000 is fine. I must say that did not go as awesome as I thought it would.
Hey, it's Tuesday.
Yeah?
Well, it's
Tuesday
also
bad?
second semester.
It's like Tuesday should be like the high point of your.
No, Tuesday's the low point.
It is?
Yeah, because here, my system is too late. It goes Friday, right? Thursday.
For focus?
Like, the best days of the week is Friday, and then Thursday is the
Like
last
Tuesday,
day.
no.
And then Monday, you still have that sleepiness. You still feel refreshed from the weekend. And then Wednesday, because it's hump day, and then Tuesday, because it's like,
We're happy.
I care more about you will be late at something.
And then he goes, okay.
You weren't here yesterday? Alrighty.
Monday starts with you. Monday starts. I think it Monday starts.
All of them Mondays are overrated.
Okay. Grading your homework yesterday, some of you were awesome, but some of you, your work is lacking. So would you do B for me, please? Go to B. B is complete the square to write the equation in vertex form. You might want to look at this. I'm giving you yesterday's homework back graded. You might look at the completing the square on last night's to say, oh yeah, I did that right. He didn't write anything, which is good. Or, wow, I didn't like my work on computer square. I better get my act together.
Something on
Get it.
Sunday? What? Sunday is lower than Saturday.
That's what it's
I would love to. Sunday is however, I've asked about two different Saturdays. Explain it to me.
Okay. Would you, on the homework you just got back, would you look at the B on last night's homework? Did I write anything like this work is garbage? Or,
Hey, give me a check mark.
okay, a check mark means good. If it says, huh, or boo, or you stink, or something like that, then you're completing the square work is lame.
Yes, I am. What if you wrote nothing?
If I wrote nothing, that's a good sign, okay? So let's focus not just on getting the answer, which is garbage, but actually the process. How do you complete the square?
You first transfer the last number over, so
Okay,
minus 7.
so you can either move the 7 over here or push it off to the side. When you must add to both sides, or else your math is garbage.
7 plus 5.
Okay? So what do you put here? Plus 100. Can I just add 100 to one side of an equation? You cannot. Either balance the equation by putting 100 on both sides or adding and subtracting 100. Otherwise, your work is garbage.
Wait, why is it minus 7? Oh, wait, never mind.
Because okay, so what is the correct answer?
Why?
X minus 10 squared
Minus 9.
minus 93. Showing the 100 on both sides or balance the equation is required, not suggested. All right, prove the last signs, yes. I would suggest you start with area equals area.
Can we have a party if we get to start 100?
Why?
What do you mean, why?
Can we have a party on
100 is no different than 99.
You're probably running like 3 digits. Or the
Oh,
sense
so is 101.
You're one of those people that thinks birthday.
It's hard, no, that's to commemorate a birthday. There's something special about your birthday. There's nothing special about 100.
Is there any reach for birthday? We did like
I remember you said the same.
That's pretty cool.
Why don't you make this enjoy your birthday?
So you're telling me you're not gonna like celebrate like your 50-year anniversary? Like that's a big deal.
So it's 49.
But 50 is more important
At that point, you're
because it's
probably
cool.
gonna be
There's like
dead.
benchmarks in life.
Is it 51 more important than 50?
21. So why is 21 more important than 20? It just is. Why is 16 more important than 14?
If you want to talk marriage, yes, I would agree. Any greater number is better.
Just 100 by itself.
That's
Just 100.
Just a number.
Just 100.
Just a number. Would you agree that area equals area?
No.
You wouldn't agree that area of the triangle equals itself?
Oh, I do.
I think it's true. Would you agree that you could do the area twice? 1/2 AB sine C, or 1/2. No. It wouldn't matter what two sides and angle you choose. So I could do 1/2 AB sine C, or I could do 1/2 CB sine A. Cool. That's how you start the proof. Now you're eventually trying to get to A is to sine A, as B is to sine B, as C is to sine C. You're actually not, the B won't be in there, it'll be C. Okay, now you're trying to figure out, all right, now how do I get from there to there? That's the proof of the A proof.
We only have to prove A if, like.
Yeah, 2 is good. You don't have to prove all 3.
So first we get
You're
rid
trying to
of the
get
one
from there to there, so just clean it up first.
well, the 1/2.
Can you just cancel or do you have to show?
The 1/2's cancel.
You can divide out a half mentally, if you like.
Can I divide out the B as well?
These
You could
cancel.
divide out the B as well.
What?
So then it's just A, C.
Why are they looking there? Like, what the other side?
They're,
I think they're cleaning up the equations.
make their life easier.
What are you doing?
Come on, keep going.
I need to run outside too.
We kind.
Or no, straight outside.
You can see where you're trying to get to, you're almost there. Yep.
We're gonna just start with Wi-Fi.
I don't know.
Aren't you starting with the last one?
There's this
Oh,
This is what you start with. You start with something else you know to be true, like the areas are equal.
It's just 0 equals 0. That's lame.
I've given it to you.
That's not calculus. I don't want this.
Mr. Rickman,
Yep.
would this prove that I equals Li?
It's unsatisfying.
So what?
Would this prove that I equals Li?
It's unsatisfying. And I don't like
Y
it.
is 0, and y also 0, and y and x equals 0. Therefore I equals Li. It's a proof, right?
It's lame. It's a lame proof. No, I didn't.
Okay, fine, I'll do you one better.
I suppose
There, you happy?
No, it's still lame. And it doesn't work anymore.
No, it still works.
Oh, yeah.
Because that's 1 times 1.
No, it needs to be f of a. It needs to be f of a squared.
Oh, they're really pretty. Why are they so pretty?
Yeah, but then it's
Wait, why can't someone check my card here if I got it wrong?
Still
I just checked that you did.
Oh,
So check
I don't
our
care if it's right.
Fine. Those are ones I want to get something to get you.
It's like, okay. 13th, that tastes horrible because it has nutritional value.
Okay, so you have 13 minutes. You should be able to get 20 problems done.